Okay, so good day everyone. So for today's tutorial, we'll talk about compound interest. So compound interest is the interest computed on the principal and on the accumulated past interest. So compound interest is a way to earn money because you don't just earn using your original money, but also the interest you earned. So here's the comparison between the simple and compound interest. So in this area, we have the simple interest. So as you can see, it yields 10,000 while the compound interest yields 15,937. So using those tables, we can see that compound interest yields more money than the simple interest. So we have the simple interest calculated on the principal, while the compound interest calculated on the principal and the accumulated interest of the previous periods. So here's our formula for our compound interest. We have the F is equal to P, quantity 1 plus I raised to the power of N, or F is equal to P, quantity 1 plus R over M raised to the power of M times T. And then for computing the compound interest, it is equal to F, or maturity value is minus the principal amount. Okay, so whereas the I is the compound interest, and then F is the maturity value, and then the P is the principal amount or value, or the present value, and then I is the periodic rate, which is R over M, and then T is terms of years, and then N is the total numbers of conversion period, or N is equal to M times T, then M is the frequency of conversion in 1 year. So we have the conversion period, or M. Here's the for conversion. So we have the annual, and then the semi-annually, quarterly, and then the monthly. For annual, we have one period. Semi-annual, we have 2 periods. Quarterly, we have the 4 periods. And then for the monthly, we have 12. Okay, let's have an example. So find the compound amount on the deposit at the end of 3 years if 30,000 is deposited at 2% compounded. A is annually and B is semi-annually. So first, let us compute it annually. So we have F is equal to P, quantity 1 plus R over M, raised to the power of M times T. So substituting the values or the given, we have 30,000 multiplied by, quantity 1 plus 2% or 0.02 over 1, since it is an annual, raised to the power of 1 times 3. And then simplifying, we have 3,000 multiplied by 1 plus 0.02 raised to the power of 3. So using our calculators, we have the uh, maturity value of 31,836.24. Okay, for suppose that we want to, our M is to be semi-annual, we have M is equal to 2. So same process as annual, in annual or letter A. And this time it is, our M is 2. So we have 30,000 quantity 1 plus 0.02 divided by 2 raised to the power of 2 times 3. So simplifying, we have 30,000 1 plus 0.01 raised to the power of 6. So again, using our calculators, we have the maturity value of 31,845.60. Okay, now let's have for example number 2. So find the maturity value and interest if 15,000 is deposited in the bank at 4% computed quarterly or quarter for 6 years. Okay, so we have the given of 15,000 as P, and then the R is 0.04 or 4%, and the time is 6. Okay, so and then we have the M, which is quarterly. So we have substituting the values. We have 15,000 times or quantity 1 plus 0.04 divided by 4 raised to the power of 4 times 6. So simplifying, we have 15,000 1 plus 0.04 all over 4 raised to the power of 24. And then we will have, using our calculators, we will have final answer of 19,000 0.046, or 19,046.01 973. Okay, now I want you to grab your scratch paper and ball pen or pen and try to solve the problem. So Mr. John invested 100,000 in a bank fixed deposit at ABC Bank. So ABC Bank pays 8.75% compounded annually. Calculate the maturity value or the maturity amount that Mr. John will get provided he invests for 3 years. Okay, so we have the solution. So we have the given of P, which is 100,000, and the rate is 8.75% or 0.0875, and then for the time is 3 years, and then for the M is equal to 1 or annually. So substituting the values, we have 100,000 multiplied by, or quantity, 1 plus 0.0875 all over 1 raised to the power of 1 times 3. So simplifying, we have 100,000 quantity 1 plus 0.0875 raised to the power of 3. So using our calculators, we have the maturity value or amount, which is 128,613.87. Okay, so we have the practice exercise. So I want you to again grab your scratch paper and try to solve. So you can pause the video if you are not yet done, and unpause the video if you are done. Okay, so Amy, for number 1, Amy deposits 1,000 into a savings account that has 3.2% interest rate compounded quarterly. What will be the future value of Amy's savings account after 2 years? Okay, for number 2, an investment earns 2% each year and is compounded annually. So calculate the total value after 6 years from an initial investment of 5,000 pesos. Okay, so here's the answer. For number 1, we have the maturity value of 1,065.82. And then for number 2, we have the maturity value of 5,630.81. So if you got the right answer, congratulations. If not, you can go back and try to find if you miss any steps along the solvings. And that would be all. Thank you very much for listening and enjoy learning.